Prince George's County Public Schools presents HSA Prep for Algebra and Data Analysis. All problems will come from the public release problem set, which are accessible to students through the Maryland State website at www.mdk12.org. Once again, that's www.mdk12.org. HSA Prep, because now it counts.
Hey everybody, this is Mr. Owens here with your HSA prep session for today. Remember, we're preparing you all for that Algebra Data Analysis High School Assessment. So in this session, we're going to focus on Goal 3. So let's take a look at Goal 3. Goal 3 deals with data analysis and probability. It says the student will demonstrate the ability to apply probability and statistical methods for representing and interpreting data and communicating results using technology when needed. So primarily in this section, we're going to focus on our Goal 3 standards and our Goal 3 indicators, okay, and expectations. So let's take a look at our first problem for today. So the president of the student government wants to survey the students in the school about their satisfaction with the 36 after-school activities. Wow, it's a lot of activities. There are 1,000 students in the school. There are 200 freshmen. There are 200 sophomores. There are 300 juniors. And there are 300 seniors. The president suggested 3 different sampling methods. Method A, randomly choose 3 students from each of the 36 after-school activities for the survey. Method B, randomly select 100 students from the honor roll list to survey. And Method C, randomly select 200 freshmen, 20 sophomores, 30 juniors, and 30 seniors for the survey. And now we want to complete the following. The first question says, which method provides the most representative sample of the student population? Use mathematics to justify your answer. Okay, so we want to know which method provides the most, remember, the most representative sample. So now when we talk about representative samples, there are a couple things I want you to keep in mind. The first thing I want you to keep in mind is when we talk about a representative sample, the first thing is that everybody in the population has to have an equal chance of being selected, okay? So that's the first thing you want to know, equal chance. The second thing is that each person in the population is equally likely to be chosen, but choosing one person doesn't depend on choosing another. So everybody has equal chance, and there's also an independent selection. So one person being chosen doesn't necessarily depend on another person being chosen. And the last thing we want to take a look at is that there's no bias in our sample. And when we talk about bias, we're talking about excluding a group. So for example, if we take a look at Method A, Method A says randomly choose 3 students from each class, from each of the 36 after-school activities for the survey. Now, if we choose Method A, who have we left out? If we've chosen 3 students from each of the 36 after-school activities, we've left some people out. We've left out the people who are not a part of an after-school activity. Or we left out the people, because remember, there are 36 after-school activities, and we only chose 3 people from those 36 activities, so we've left some of those people out as well. So in this case, Method A would not be a good example of a representative sample. Let's take a look at Method B. Method B says randomly select 100 students from the honor roll list to survey. Now, the question is, well, what's the bias in that? Now, as much as we would like to think that everybody makes the honor roll, we have to think about the fact that everybody doesn't. So that may not represent the entire school population. And those of you who are not on the honor roll, I know that you all are working diligently toward being there next quarter. So keep up the good work. So Method B wouldn't be a good sample because, remember, we're leaving out the population that may not have made the honor roll that quarter. So now next quarter, that might be a better sample because everybody in the school is going to make the honor roll. All right, let's take a look at Method C. Method C says randomly select 20 freshmen, 20 sophomores, 30 juniors, and 30 seniors for the survey. Now, in this case, have we given everybody an opportunity? So we've covered each of the 4 classes. We covered freshmen, sophomores, juniors, and we got to give it up for class of 09. So we've covered all of our classes, and we've also gotten the same percentage in our sample as we have in our population. Now let's take a look at why that's true. So we said in the school there are 200 freshmen. So freshmen, we have 200 freshmen. So now let's look at the school let's compare the school, and we're going to compare the sample. So, freshmen. In the school, there are 200 freshmen out of 1,000 students. In the sample, there are 20 freshmen out of 100 students. For sophomores, there are 200 sophomores out of 1,000 students in the school, and there are 20 sophomores out of 100 in the sample. Juniors. All right, the class of 2010. There are 300 juniors out of 1,000 students, and there are 30 in the sample. There are 30 students out of 100. 30 juniors out of 100. Seniors, class of 2009. All right, so seniors. There are 300 seniors out of 1,000 in the school, and then there are 30 seniors out of 100 in the sample. Okay, now let's figure out the percentage of freshmen, sophomores, juniors, and seniors that are represented in the school as well as in the sample. So let's take a look. So, all right, so we have 200 freshmen out of 1,000 students in the school. So 200 out of 1,000, that gives us 2/10. Now 2/10 as a percentage is going to be 20. So 20% of the school is freshmen, made up of freshmen. In our sample, we have 20 divided by 100, which also gives us 2/10 times 100. So 20% of the students in our sample are also freshmen. Now, sophomores and freshmen have the same number of students, so we can put the same values for sophomores in the school and in our sample. Let's take a look at the juniors. So for juniors, we have 300 juniors out of 1,000 students. So that would be 3/10 times 100. That gives us our percentage. So 30% of the school is made up of juniors. Let's take a look at our sample. We have 30 out of 100, which is 3/10 again, times 100 is 30%. So 30% of our sample is also juniors. Now we know they're the same number of juniors and seniors, so the same values apply. So in looking at comparing the school to the sample, we can see that we have a pretty representative sample. So in this case, this is why method C would be the most representative sample. It's the most representative sample is because, one, everybody has a chance of being a part of the survey. Number two, selecting one person does not depend on selecting another person. And number three, our sample is not unbiased, and it's representative. Same percentage of students that are in the sample population also represents the same number of students that are in the school. So that would be part of our reason why method C is correct. So you may want to use what we've written here as part of your justification, because the question does say justify. And when we talk about justification, we're talking about explaining why your answer is correct. It's not is your answer correct, but why is it correct? And so using mathematics to justify is what we did here. Okay? Let's take a look at the second part of that question, because it was a two-parter. So the second part of the question says, use mathematics to justify why each of the other two methods does not provide a representative sample. Okay, so a couple things that you may want to include in your justification for why the other two samples are incorrect are a couple words that we just mentioned, but I'm going to put them down. So a couple things you want to consider when you're dealing with a representative sample. Representative sample. And that's a good word, representative. That means you're trying to represent the population. You're trying to represent the people. So representative sample, the first thing you want to look at is you want to look at equal chance. Equal chance. So everybody has an equal chance to be a part of the sample. You also want to look at independent selection. Independent selection, and is representative, say representative of the entire population. Okay? So equal chance independent selection representative of the entire population. One more thing we want to talk about. Unbiased. Unbiased. So we don't want to exclude any groups when we talk about our representative sample. Now, equal chance and independent selection, those also can be referred to as our principles of simple random sampling. So principles of simple random sampling. Okay, so when you go to justify the second part, second question, those are some things that you may want to make mention of. Equal chance, independent selection, talk about how the methods are not representative of the population and how they may or may not be unbiased. Okay? So now let's move on to our next question in our Goal 3 lesson. So our next problem involves Richard. Richard's conducting a survey. Richard surveys a room of 26 adults and finds that of the 12 men, 5 are married and 7 are single. Of the 14 women, 8 are married and 6 are single. Richard randomly assigns each person a number and places a card with each number in a hat. What is the probability that Richard will select a card with the number assigned to a married man? Okay, so when we're talking about probability, remember we're trying to find the number of favorable outcomes over the total number of outcomes. So when we talk about our probability, so probability is, or our P, is the number of favorable outcomes over the total number of outcomes. So number of favorable outcomes over total number of outcomes. So our probability, our P in this case, it stands for probability, is the number of favorable outcomes over the total number of outcomes. So our total number of outcomes, in Richard's case, would be 26. Right? And we want the number of favorable outcomes in this case is, if we look at our question, it says, what is the probability that Richard will select a card with the number assigned to a married man? So we're looking for married men. Okay, so in our problem we see that Richard has 12 men. There are 12 men in the group. And of those 12 men, 5 are married and 7 are single. So we have 5 married men. So that means our number of favorable outcomes in this case is going to be 5, because there are 5 married men out of the group. So let's take a look for our answer choices and see which one corresponds to our answer. Looks like it's answer choice A. So 5 out of the 26 numbers would correspond to a married man. So the answer to this question would be answer choice A, 5 out of 26. So keep in mind our formula for probability. Remember, probability or theoretical probability is our number of favorable outcomes over the total number of outcomes. Okay? Let's move on to our next question. Our next question involves Jose. Jose is also conducting a survey. There's a lot of surveys going on. So Jose conducts a survey of 30 people to determine how many times a person ate at a restaurant between January and July. The results are shown in the stem and leaf plot below. Okay, so in our stem and leaf plot we're representing the number of times a person ate at the restaurant. So here it says, based on the survey results, what is the probability of randomly selecting a person who ate at a restaurant 20 or more times between January and July? Now, one of the things about our stem and leaf plot is that it has a little key. Our key down here looks kind of like this. And so it says when there's a 2 in the stem and there's a 0 in the leaf that represents 20. So now we want to know, based on our survey, what's the probability of selecting a person who ate at a restaurant 20 or more times? So 20 or more times. That's the key. So let's take a look at our survey. So I can see from our stem and leaf plot that somebody ate there 20 times. Another person, 23. Then we have 24, 26, and 26. Next, we have people who ate in the 30s. We have 34. And we have 34 twice. We have 35 3 times. It must be a good restaurant. 3 times. And then we have 37. And we have 38. For the 40s, we have 3 people who ate there 43 times. Woo! 43 times. We have another person who ate there 46 times, and one person who ate there 47 times. Nobody in the 50s, but we do have somebody in the 60s. Somebody's gone to the restaurant 63 times. That's all right. Must be good, some good eating. Okay, so now let's take a look at the number of times a person ate at the restaurant 20 or more times. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 17 people who ate at the restaurant more than 20 or more times. So we have to include the 20 because the problem says 20 or more. So we have 17 people. So let's go back to and think about our probability. Remember, probability is the number of favorable outcomes over the total number of outcomes. So our total number of outcomes in this case is 30 because we had a survey of 30 people. The number of favorable outcomes are the number of people who ate at the restaurant 20 or more times. And we said that is 17. All right, everybody. I hope you enjoyed this session, helping to prepare you for the high school assessment in algebra data analysis. I wish you all the best on the test. Remember, we're striving for 412 and beyond. I'm Mr. Owens, and I'll see you later.